Welcome to Chapter 17. So Chapter 16 and 17 go hand in hand. They're both using a one mean z process and a normal distribution. But in Chapter 16, we found a range of values to estimate our population mean. And in Chapter 17, what we're going to do is we're going to test a claim about that population. So maybe the claim is that the average height of students at Western is 6'6", and you think that the average height is less than 6'6". And so that's what we would be looking at testing. All right, so the process for both of these is pretty similar. For the confidence interval, we start out by identifying our population, pulling a random sample of some sort, and then we're going to calculate our sample mean. And we represent that sample mean with x with a bar over the top of it. And then that sample mean is going to become the center of our interval. Then we'll have that margin of error on either side. And we're going to take that interval and apply that to our population. And we're going to say that we think our population mean is somewhere within that interval. So in Chapter 17, it's going to start out much the same. We start by identifying our population. We pull a random sample of some kind, and we calculate our sample mean x bar. Then, instead of using that sample mean as the center of an interval, what we're going to do instead is we're going to calculate something that looks a lot like a z-score, called a test statistic. And then we're going to look at the probability that's associated with that score. And we'll use that to decide whether we think the alternative hypothesis is more likely or not. All right, so let's look at an example of this. Suppose I claim that I can make 75% of every basketball free throw that I shoot. Yeah, that probably sounds a little bit unbelievable. And so to test my claim, you asked me to go to the gym and shoot 25 free throws. Let's look at two possible scenarios here. The first one is, suppose I make 19 out of 25 free throws. So it would be 76%. Does it seem plausible or realistic that my actual free throw average is 75%? Well, yeah, 76, 75, those are really close. That does seem pretty plausible. Suppose, though, on the other hand, that I only made 11 out of those 25 free throws. Does it seem likely, if that's a 44%, that my real average is 75%? And that's probably not, right? There's a big difference between 44 and 75%. So this would be evidence that most likely I'm kind of bragging a little bit and exaggerating how good of a free throw shooter I am. I'm not really a 75% free throw shooter. So the way that you kind of come on that conclusion, or what your reasoning is based on, is we're thinking about things that we talked about in Chapter 15. So what would happen if the claim was true and we repeated this sample over and over and over again? Right, so we're looking at those ideas that came with the law of large numbers and the essential limit theorem of just repeating that sample over and over and over again. So in other words, I go out every day for the rest of the semester and I shoot 25 free throws and I record how many I make. So if I did that over and over and over, the outcome is so unlikely from my claim that it gives you strong evidence that my claim is not true. Or in other words, if I really was a 75% free throw shooter, I would almost never make as little as 11 out of 25 free throws. And so that gives you evidence that I'm probably exaggerating how good of a free throw shooter I am. All right, come back in the next video and we'll look at what a hypothesis test is and these null and alternative hypotheses.